In this video, we are going to see the polar coordinates. When we are talking about the rectangular or Cartesian coordinate, we used to talk about the x and y. So we have x value and y value in the Cartesian coordinate. But here we are talking about the polar coordinate, and polar coordinate represented by r and theta, and that r is stands for radius and theta is the angle, because we are basically locating a point which is on a circle with a particular radius, right? And that point is actually moving along this circle. If it's the radius 1, we can see there is a three circle I draw. If the radius 1, radius 2, radius 3, so point is rotating on the circle, along this circle, with the certain number of angles. And the angle, always we see when it's going to the, we always go with the positive x-axis and anti-clockwise direction, which is positive angle. And when we are going negative direction from the positive like x-axis, then it is our, or from the x-axis it is our negative angle. So angles can be negative when we are going to the clockwise direction, and when we are going anti-clockwise direction we are getting the positive angle. So like Cartesian coordinate, where x and y can be either positive or negative, similar in a polar coordinates, r and theta can be also positive or negative. It means r can be positive, theta can be negative, or r can be negative, theta can be positive, or both can be negative, okay, or both can be positive. That's I already showed here. So there are four ways it can be, you can see r and theta, as we have x and y. But in this case the point is moving along the circle with the different angle. All right, now how we can see or graph the points when it's given in terms of polar form. As I said, you will see kind of radius and also the angle. Let's say we start with an example, like we have a point which is 360 degree. So 3 is the radius and 60 degree is for the theta. As I said, it, you can see this sort of like the angle, it can come like minus 60. So how we can look at that point into that graph. And in a xy, when we have a Cartesian coordinate, the points is just changing like horizontally, like x direction, and also vertical direction for y change. Okay, but in this case the points is changing with theta, so along with the circle and with the different angle. So it's not changing vertical and horizontal direction, it's a circular rotation, circular direction, right? Now, so I am just taking 360 degree, but I want to see if that 360 is coming both positive, one negative, and the next one like 3 negative and 60 is positive degree, and the next one is if it is minus 3 minus 60 degree, then where the points will be in that graph. Okay, now we have, like, let's say this point is A, this is B, this is C, this is D. Okay, then how we can locate these points into this graph. So now you can see A is 3 and 60, so 1 2 3. So this is our radius 3, because we are just considering this is the radius 1, radius 2, radius 3. So this is our radius 3, 60 degree. So as I said, when you are going 6 positive angle, you have to go anti-clockwise direction. So if you go anti-clockwise direction to 60 degree, let's say the point is so it's a 60 degree, not 30 degree, so somewhere here, right? So it's, so we can imagine that that is basically is creating 60 degree with that angle. So this is 60 degree we are guessing, right? So this point is our A, so which is 3 and 60 degree. So this is the point on that circle with the radius 3, and the angle created by OA, like let's say if it's the center O, then that angle is creating 60 degree with the axis. Now if you go for 3 and minus 60, so again we are going 3 the radius, but minus 60 you have to go to the clockwise direction to minus 60, and it will be somewhere here, because we can imagine that this is our 60-degree angle. If I just change the color, negative angle, so this is the negative angle we are guessing. Okay, so that's why we are putting negative 60 here. Okay, so 3 negative 60, and this is the point which is B. So we can say this is our B. And if I ask you where is C, minus 360 degree, then you can say, okay, some teachers they explain, if you have a 3 and 60 here, A is the 360, and if you just extend this line like that, whatever, if you extend it like that, so if you travel negative direction, or if you travel that just opposite of A direction, then you are getting negative 360, because A is 360. So if you go that negative direction, which is going negative 360, which is C. But the way uh, doing that is confusing when we are locating the same points, and then same points can be represented by 4 different ways. Then you will feel it's confusing. So what we can do, we can just say, okay, in order to get minus 360, what we can do, we can just go 1 2 3. So this is the negative direction of R, so negative 3, and then go 60-degree positive direction. So positive direction means anti-clockwise. So from here, if you go anti-clockwise, then obviously you have to go to that direction, which is giving the positive direction, because anti-clockwise, and then you are reaching here, and you are creating 60-degree on that part, right? So this is 60-degree anyway. So this part minus 360-degree, this point, so which is C. And now D is minus 3 minus 60. So again what we can do, we can just go 1 2 3 minus 3, and so from here to 60-degree we can guess it is somewhere here, and then just if you add that point, that the line I'm showing just to make it, this is basically 60-degree, but we are counting the clockwise direction to make a minus 60-degree, and this is actually the point D. So our D is minus 3 minus 6. What we are doing? We are doing minus 3 direction and then going to clockwise direction to reach that 60-degree clockwise direction, which reaches D. And that D is telling is a minus 3 minus 60-degree. That's how we can locate the point into the graph. Now, you might say that the same point we can represent in terms of 4 different way we can represent. So let's say we have a, I can just draw it. If I can draw a small circle here, I'm just thinking these are our, okay. So let's say that just we are considering that circle 1 radius, 2 radius, 3, and this is our axis, right? Now I'm asking just find the point minus 3 or 360, for example. How we can, this is 360, I'm just copying the same point, so it's A, whatever we had A, which is 360. What are the other ways this point can, we can count this point? So you know this 60-degree and 3, we are just going 3 and then positive 60-degree, which is if you go like that, this is giving you positive 60-degree, right? Now if I say is there any other way we can represent this angle or this point? Yes, we can represent this point, because if you go 3, you are reaching here, that's fine. But if you want to come 3 and the other way around, like if you go to the like let's say I'm using the red color because we are going to traveling to the negative direction, then what is the angle? If I go, if I travel and reach that angle, that point, you can reach that path as well. You can go to that point by using the red path, and then what is that point will be 360-degree minus 60-degree. Then that point will be, we are going 3 and then following the red path, which is 360 minus 60 giving you 300. All right, so this is the another, this is it, that should be negative, as I said, because we are traveling to the clockwise direction with the red path, right? So now it's a negative 300. Now if I go to the negative 3, 1 2 3, negative 3, and then going to the end again, we first go clockwise direction, so follow the clockwise direction from negative 3 to the clockwise direction, like to reach there. So when you're going clockwise, again it's a negative, but what is that negative angle? 180 degree minus 60 degree, am I right? So from here to here it is 180, but we are starting from negative 3, and 180 minus 60 and 120 degree, and it would be negative again because we are going to the clockwise direction. Okay, now if I write down this one in other, or other value, we can write down also minus 3. Let's say we are going minus 3, but from minus 3, instead of going the clockwise direction, we are going from minus 3 to anti-clockwise direction. Let's say we are traveling that direction, anti-clockwise, and reaching there. Okay, so if I traveling anti-clockwise and reaching there, you are basically traveling 180 plus 60, and then it will be positive angle. 180 plus 60 is 240 degree, and it is positive. 180 up to from here to here 180, then we are adding that 60 degree, and it is anti-clockwise direction, which is giving us 240 degree. So basically each point anywhere in that circle, or anywhere, any circles, any points lying, we can represent that by the four different values. As I said, the any point, the r and theta can be positive or negative. And why it is very important, sometimes question asks what are the other three ways you can see the point 360 degree, 3r, and then 60 degrees the theta. So then you have to write down other three values. And also it is important when we are going to convert the polar coordinate to Cartesian coordinate, students get often confused when they have a theta negative or r negative. But if you know that, you can write down that points in terms of both positive, then it will help you to understand how to convert that into Cartesian coordinate. Hope that video helps you, and if you'd like to see more videos, please subscribe my channel.